Economic equivalence is a mix of interest rate and the time value of money. What I mean by that is that money is attached to some time value, right? And what happens is that if you have $100 today, and let's say the interest rate per year is 8%. So from 1 year from now, so right now it's year 0. 1 year from now, this interest rate would be $108. The concept of economic equivalence means that you could have $100 today and it would be equivalent to $108 a year from today. And this is the concept that we use when we decide which cash flow we should choose. If we are given alternative cash flow, for example, you can either have $10,000 today and no money 5 years from today. You have another cash flow which gives you an amount of a certain equal amount. Now these two cash flows are obviously different, right? And then there's other types of cash flows where it's really just doesn't really follow any pattern. Now these are 3 different cash flows, so we can now figure out at this point what the amount is worth, or at this point what the amount is worth, or at this point what the amount is worth, or any point on any cash flow we can figure out what the amounts are worth, or the VN at this period, or VN at this period, and VN, or where N would be 4. N would be 4. Instead of choosing this point, let's choose this point, so N would be 4. Now, because we have a value at this particular point, we can compare the values and pick the one that's the highest, because we want the most money. So that's what economic equivalence is. You have a set of cash flows or alternative cash flows, and it helps you determine which one you want. Now that we have a sense of what economic equivalence is, let's just drill the concept by doing a simple example. Suppose you have $2,000 and you want to deposit it at the bank at 12% interest, compounded annually. So what is the economic equivalence of your deposit 5 years from now? So it's at 12% interest per year, because it says compounded annually, and your initial amount or your principal value is $2,000, or your present value. So let's start by drawing out our cash flow diagram. You want to deposit $2,000 at year 0. And you want to know at 12% compounded annually, what is the equivalence of your deposit. So you just deposit $2,000 now, and you want to know how much it's worth 5 years from now. You want to take it out 5 years from now. So how much is it? So 1, 2, 3, 4, and 5. 5 years, right? Well, we can just use our compounded interest formula, which is future value. We're trying to find out the future value at 5, right? We don't need to write the year 5. Is equal to present value times 1 plus I to the power of number of periods. The number of periods is equal to 5. So N is equal to 5. I is equal to 12%. And P is equal to $2,000. So F is equal to 2000 times 1 plus 0.12, convert the percentage to decimal, to the power of 5, which equals to this value over here, $3,524.68.